Beneath the vast oceans, technology takes a bold leap forward with Northrop Grumman's Manta Ray, a never-before-seen extra-large autonomous underwater vehicle engineered to endure the planet's most extreme and inaccessible environments. Grumman's Manta Ray glider vehicle design features state-of-the-art technology that takes underwater scientific exploration and military operations decades into the future. From imitating the Manta Ray's movement to advanced energy-saving technology that allows the vehicle to anchor on the sea floor and hibernate in a low-power state, Grumman's design is a game-changer. The Manta Ray can travel unlimited distances and durations at extreme depths and relay and receive information for military or scientific purposes. As if that was not enough, Grumman's UUV can carry a devastating payload, be it missiles or torpedoes, for use against hostile forces. Manta Ray is the next tier in uncrewed underwater vehicles, and it's only a matter of time before they join the U.S. Navy in the Pacific for the conflicts to come in the region. Unmanned underwater vehicles, or UUVs, also known as underwater drones, are robotic systems designed to operate underwater without a human crew on board. These vehicles are used in various roles, ranging from military and defense operations to scientific research and commercial programs. UUVs are typically categorized into two groups: autonomous underwater vehicles, or AUVs, and remotely operated vehicles, or ROVs. These underwater drones are equipped with sophisticated navigation systems, such as sonar, GPS, and inertial navigation systems for optimal coordination in the battlefield or zones of exploration. Other models feature advanced communication instruments, such as acoustic signals and satellite communications, to upload or receive information that coordinates their sensors, cameras, and thermal detectors. In partnership with Northrop Grumman and the Defense Advanced Research Projects Agency, or DARPA, the U.S. Navy launched the Manta Ray program to provide the fleet with the latest class of unmanned sea vehicles. The program's objective was simple: develop UUVs that can operate for extended durations without needing human-present logistic support or maintenance to tackle current challenges that halt scientific explorations and underwater military operations. Launched in 2020, the Manta Ray program also seeks to demonstrate innovative technologies that can introduce long-range payload-capable UUVs. According to Dr. Kyle Womer, DARPA program manager for Manta Ray, quote, "If successful, this new class of UUV will give the combatant commander an amplification of capacity without disrupting current operations by remaining independent of manned vessels and ports once deployed." Womer and DARPA have also stated in the past that Manta Ray plans to advance critical technologies that will benefit future UUV designs, including novel energy management techniques for UUV operations and undersea energy harvesting techniques at operationally relevant depths and low-power, high-efficiency undersea propulsion systems. As part of scientific operations, the program will also provide new low-power means of underwater detection and classification of hazards or counter-detection threats, mission management approaches for extended durations while accounting for dynamic maritime environments, and unique approaches for leveraging existing maritime datasets and exploiting novel maritime parameters for high-efficiency navigation. Last, but no less critical, is Manta Ray's objective to develop new approaches to mitigate biofouling, corrosion, and other material degradation for long-duration missions. As the program's name implies, Northrop Grumman drew inspiration from nature to develop its highly advanced UUV, stating in an official press release, quote, "A manta ray is a social creature that frequents the tropical waters of the Great Barrier Reef. Their curiosity and playful nature make the manta ray a favorite among scuba divers. Inspired by the graceful glide of these magnificent sea creatures, Northrop Grumman is creating a new class of UUV for undersea missions." Gathering its vast knowledge from over 50 years of undersea innovations, Northrop Grumman named its program after the massive winged fish and designed an underwater vehicle that mimics its movements. Phase 1 of the Manta Ray began in 2020, and original footage emerged for the first time in 2021, showcasing a colossal Manta Ray-like UUV gliding a few feet off the ocean floor. During the video, the Manta Ray deployed a smaller signal as part of its payload to emit a signal and then return to the vehicle. Months later, in 2022, Grumman revealed computer-generated footage of the vehicle, providing more details about its innovative extra-large glider. The video showed the Manta Ray being propelled by 4 small propellers. Alluding to the video, Dr. Womer said in the Voices from DARPA podcast that, quote, "The Manta Ray project came out of a need to understand more about the ocean environment. and have underwater vehicles that last longer than the order of a couple of hours or days. Manta Ray is an autonomous underwater vehicle that operates on its own, harvesting energy and completing whatever mission it's been given. This unique energy-saving technology allows the Manta vehicle to anchor on the seafloor and hibernate in a low-power state. Furthermore, Northrop has also designed energy harvesting technology that can power the Manta Ray for unlimited distances and durations through their Mission Unlimited unmanned underwater vehicle station, developed alongside Seatrek, a renewable energy company. This station is a combination of two innovative technologies. The first one is Seatrek's thermal energy pod, which extracts energy from the ocean's thermal gradient. The second technology is Northrop's self-insulating wet-mate electrical connector, which enables underwater connections. This combination allows electricity production from the temperature difference between the warmer surface water and the colder water below the surface. Adding to the innovations, Manta Ray will also be able to transfer large volumes of information to a satellite or allied vessel through its connectors of the Mission Unlimited UUV station, minimizing human intervention. In a press release, Brian Theobald, chief engineer for Northrop's Manta Ray program, stated how the process works. Quote, "Data bubbles are tiny electronic devices that store data. When released from the station, they float to the surface and begin using their RF satellite communications antenna to transmit data to shore, a satellite, or a ship." Beginning February and March 2024, Grumman's Manta Ray prototype underwent several tests in secluded areas off the coast of Southern California. Northrop Grumman successfully shipped the Manta Ray prototype in separate parts from its build location in Maryland to its test location in California. This successful transportation and assembly process proved that the prototype could be quickly deployed around the globe without taking up valuable pier space at naval facilities. Dr. Womer stated in a press release, quote, "Shipping the vehicle directly to its intended area of operation conserves energy that the vehicle would otherwise expend during transit. Once deployed, the vehicle uses efficient, buoyancy-driven gliding to move through the water. The craft is designed with several payload bays of multiple sizes and types to enable various naval mission sets." Womer's team successfully conducted full-scale in-water tests of the Manta Ray, providing them with essential data about the prototype's at-sea hydrodynamic performance and submerged operations. Furthermore, DARPA also tested the vehicle's multiple modes of propulsion and steering, including propellers, control surfaces, and buoyancy. Dr. Womer told the press, quote, "Our successful full-scale Manta Ray testing validates the vehicle's readiness to advance toward real-world operations after being rapidly assembled in the field from modular subsections. Cross-country modular transportation, in-field assembly, and subsequent deployment demonstrates a first-of-a-kind capability for an extra-large UUV." Until now, neither Northrop Grumman nor DARPA have provided more details regarding the actual size of Manta Ray. Nonetheless, a picture showing Dr. Kyle Womer and a member of Northrop Grumman standing atop the UUV says a lot, providing more insight about the vehicle's colossal size. The U.S. Navy's request to field its forces with state-of-the-art uncrewed underwater vehicles is slowly coming full circle as tensions rise with China and North Korea in the South China Sea. It's only a matter of time before Northrop Grumman's Manta Ray and Boeing's extra-large UUV join the U.S. Navy's arsenal to patrol friendly and hostile waters alike in the Pacific. Collisions with China's uncrewed underwater vehicles are inevitable. The Asian country has been closely monitoring its neighbors and the United States Navy regarding the latest developments in naval expansion. Since 2022, the Chinese Navy has attempted to hop on the train of extra-large uncrewed underwater submarines after the US, UK, and Australia unveiled their first XLUUV programs. Satellite imagery of Sanya Naval Base in Hainan in the South China Sea has revealed two different XLUUVs currently under development by the Chinese PLAN. According to analysts, these two vehicles are too small to be regular submarines and too big to be swimmer delivery vehicles, or SDVs. One of these vehicles is over 52 feet long and 6.4 feet across and features a streamlined bow with a tail and two propellers. This size and design are similar to the U.S. Navy's Orca, and one was recently unveiled at the NAVDEX 2023 Defense Exposition in Abu Dhabi. However, little information is known about its capabilities. In any case, the clash of UUVs between the U.S. and China would surely change the naval strategies of both nations as they become available in the following years. As for the Manta Ray, Its top-notch capabilities and state-of-the-art technology open a new generation of underwater exploration, security, and naval operations for the entire globe.